Hello, Mr. Gazda here, 138, Applied Physics. Check this out. So, you should have this. You're going to need a calculator too, and the reference table. But first, part of the quiz will be this. We did this in class, and it's measuring the angle of incidence, the angle of refraction. So I drew one here as an example. Let's show you how to do this just again. I know you can't do this for homework. You don't have one at home. So what I'm going to do is you want to draw in this 90-degree angle. So I'm getting this right at the point, the vertex there of the angle, and getting that there. It's a little hard for me because I can't get my head directly on the can't get my head directly over it because the camera's in the way. And then I draw in the normal here. So it's a 90-degree angle, and usually a dashed line is the way to do it because it will differentiate between the actual rays of light and the normal. So what we're going to measure, this is the angle of incidence hitting the surface, and this is the angle of refraction right here. So the way you want to, I have to measure this angle. So to go like this, you have to put that right at the vertex. I'll maybe mark that right there, and then you have to keep this on the on that line right there. Now what you want to do is see, it's not 150. You got to be careful. Because you're measuring this angle, it's got to be less than 90, so it goes like this, and the scales here are a little bit crazy. 10, 20, and that's 30, but so 31 is there, 32. This is actually about one less than 30, so maybe we'll call that about 29. So this is 29-degree angle, okay? 29 degrees, and then this one here is going to be a smaller angle just by looking at it, and it's going to be a little, so what I would need to do is I need to extend this a bit. I need to extend this a bit so I could see it better. So I'm going to go and extend it as if it went off, it's not going to do that, but I'm just doing it to measure this angle with the protractor that I have. So I'm putting this on 90 here, and then I don't have the normal there, but I have it right here. I'm doing it right there. And what we have right here, well, this is 10. It's probably between 9 and 10. So maybe we'll call that 9 degrees. 9 degrees. But that's how you do it. Hopefully you know this from class, but it's a reminder. I know you don't have it at home, but you'll need to know that for the quiz. So let's get on to the calculating the index of refraction. What we're trying to do is the index of refraction of this material. Okay, we don't know what it is. It's some kind of glass-like material, plastic, liquid, something where light flows through. The light ray here goes in at 32-degree angle from the normal, and it gets refracted to be 13 degrees. So this must be a higher index of refraction. Light travels slower in it than the air. Okay, this is the formula here. Where you're going to find the formula is on the reference table, and it's on page 5 of the reference table. It is right here. Okay, N1 times sine theta 1, N2 sine theta 2. And these are angles and the absolute index of refraction. And the key thing is the index of refraction are on page 2 of the reference table. Here, they're all listed. Air, they make air 1.00, which is going to be nice for us. It's going to make our formulas work out better. And we're going to be calculating for whatever our material is. We don't know what our materials are, but here are some of them here. Index of refraction here. So, let's just do these. Let's do these. So what you're going to do, so I wrote the formulas out to save some time. N1, this is air. I'm going to call this theta 1, and this is theta 2, and we're trying to find out what the index of refraction is here. So this is 1.0. 1.00 times sine of 32 equals N2 sine of 13 degrees. Okay, so let's do this. So my calculator, I think a lot of calculators do sine and then 32. This one is 32 and then sine. And I'm going to write that down. So that's times 1, so that's kind of 5,299 divided by, so it's going to be N2, and I'm going to find this number here, and then I have to divide both sides. So it's going to end up being sine 13. So I'm going to round this to 4 decimal places just to make my math work out better, equals N2. Okay, so I'm going to do 0.5299 divided by 0.2250 equals this. Yeah, this is a high number. This is in the range of like even a diamond point, and I round it to 2 decimal places, so that's going to be 3/6 equals N2. And it's just a ratio, so there's no units on it. Okay, that's that. The second one here is going to go like this. So again, air is 1.00 times sine 57 degrees equals N2 sine of 38 degrees. Maybe I'll do the whole thing out here. So sine of 57 sine is that. So I'm going to do 1.00 times 0.8387 equals N2 times sine of 38 sine 0.6. So that is 0.6157. Okay, now to get N2 alone, right, you do this. You remember this from what we've done all year in math, so that cancels out. That brings this to be over here. We do to one side, we do to the other. 57. And then that becomes just that because it's times by 1. So basically our math is 0.8387 divided by 0.6157 is 1.36. So the answer here is 1.36 equals N2, the index of refraction of this material here. Okay, on to the back. This one here, I have I'm going to call that theta 1, 39-degree angle and a 20-degree angle. So 1.00 times sine 39 degrees equals N2, that's what we're trying to find again, times theta 2, or sine theta 2, sorry, sine of 20. Okay, and then my 39 sine. So, and because it's times 1, I could just write that down. 0.6293 equals N2 times sine of 20. 20 sine 0.3 20, yeah. So that's 0.3420, and then I will divide to get N2 by itself, 3420, right? On both sides I need to do that too. 3420. They cancel out. So to get, I just have to do 6293 divided by 0.3420. 1.84. 1.84 rounded is your index of refraction of the material of this block. Okay. And what else we have? We have this one here. So light's coming this way, so I'll do 1.00 times sine 59 degrees equals N2 sine of 27 degrees. So 59 sine is 0.8572 times N2 sine 27. So what's that number there? 27 sine is 0.45, and I'm going to round that to, so that ends up being that. Okay, so I have to divide it by 0.4540, cancel out, do the same thing on this side, 0.4540, and what I get, and there's probably easier ways to do it on your calculator, this is an old calculator, 0.4540. 1.8, I round to 1.89 equals 1.89 equals N2. Okay, that's what you need to do. Homework 138. I'm Mr. Gazda, and I approve of this homework.